Welcome to Learning Path 5, Manage Infrastructure as Code using Azure Technologies and Desired State Configuration. Throughout these videos, you'll discover the principles behind infrastructure as code and configuration management, learn how to create and automate Azure resources with tools like Azure Resource Management templates or ARM templates, Bicep, and the Azure CLI or command line interface, and see how Azure automation and desired state configuration can streamline deployment and ensure consistency. We'll review the key takeaways, equipping us with the practical skills and how to automate, configure, and manage cloud environments efficiently using Azure and desired state configuration. And in this video, we will discuss the concept of infrastructure as code and cover some of the tools related to that concept. So let's get started. When managing environments in the cloud, configuration of infrastructure can quickly become a headache if handled manually. Manual configuration is not only error-prone and hard to reproduce, but it also slows down deployments and increases the risk of bugs sneaking into production. Imagine trying to set up a new server from memory or scatter documentation. Mistakes are almost inevitable. And if a machine crashes, getting everything back up and running can be a real challenge. This is where the concept of infrastructure as code shines. By defining our environments and its configuration in scripts, we create executable documentation that's easy to reproduce, debug, and scale across multiple servers. This approach helps maintain consistency between development and production, making deployments smoother and less stressful. Another key benefit of infrastructure as code is that bugs become easier to track and fix, and we can increase our deployment cadence without piling up incremental changes. Instead of relying on manual steps, scripts automate the setup, reducing human error and making it possible to roll out updates confidently. Configuration management is all about making sure our application and its environment are set up exactly as needed every time, on every server. So instead of relying on the manual steps and documentation, which, as we know, can be error-prone and hard to scale, configuration management uses scripts to automate the setup. The setup defines not just how the application should run, but also the infrastructure it depends on, making the whole process lighter, faster, and much more reliable. By treating configuration as executable documentation, we can easily reproduce environments, catch bugs quickly, and keep everything consistent across our development and productions. When managing infrastructure as code, there are two main ways to define how environments are set up. Imperative, also called procedural, and declarative, sometimes referred to as functional. The imperative approach is all about specifying the exact steps needed to reach a desired state. So think of that as detailed instructions for every action. This method can be useful when environments change frequently or require complex step-by-step logic. On the other hand, the declarative approach focuses on describing what the final state should look like without worrying about how to get there. This abstraction makes it easier to use and maintain, especially for straightforward deployments. Azure Resource Manager or ARM templates are a great example of declarative automation where we simply state the desired outcome and let the system handle the rest. There is no single best approach. Each has its strengths depending on your needs, and declarative methods are generally preferred for ease of use and consistency, making them ideal for most cloud deployments. However, imperative scripts shine in scenarios where you need granular control or there are going to be frequent changes. Idempotent configuration, or configuration that doesn't change, is a cornerstone of modern DevOps practice. It allows teams to automate the setup and maintenance of environments confidently, knowing that their scripts will consistently produce the intended outcome. So whether you're updating existing resources or spinning up fresh environments after a failure, idempotence ensures that your infrastructure remains stable and predictable. This approach reduces human error, speeds up recovery from crashes, and helps maintain consistency between development and production environments. By treating infrastructure as code and embracing idempotent operations, organizations can achieve smoother deployments and more resilient systems. Now let's talk about how to create Azure resources using Azure Resource Manager templates. When deploying resources in Azure, using Azure Resource Manager or ARM templates can make our life much easier and our deployments far more reliable. ARM templates allow us to define infrastructure as code, meaning we can describe exactly what resources we need and how they should be configured and the order in which they should be deployed, all in a single reusable file. This approach speeds up deployments, makes them more repeatable, and helps ensure consistency across environments. By mapping to resource dependencies, ARM templates enable us to deploy multiple resources in the correct order, reducing manual, error-prone tasks, and making troubleshooting much simpler. When working with the Resource Manager, everything starts with the JSON. It's a simple text-based format that organizes the data into key value pairs. The ARM template uses JSON to define the infrastructure that we want to deploy, making it easy to read and share and automate. Each template is made up of several key sections: the parameters, which let us customize deployments, variables for reusable values, functions to perform calculations or other logic, and the resources, the actual Azure surfaces we will be deploying, and any outputs. So this would be anything as an output of a result of a variable, let's say. The structure helps us build flexible, repeatable solutions that can be tailored for different environments or needs. When deploying the resources in Azure, it's common for some resources to depend on others. So think of a virtual machine is going to need a storage account or a network interface before it can be set up. Our ARM templates make it easy to define these relationships using the depends on element. By marking which resources must be created first, you ensure that everything is deployed in the correct order. This reduces errors and makes your infrastructure setup more reliable. You can also use the reference function to link resources together, which helps automate complex deployments and keeps everything organized. When building our cloud infrastructure, modularizing our ARM templates is a best practice, and that makes our deployments more flexible and maintainable. So instead of creating one massive template for everything, we're going to break our solutions into smaller reusable pieces. And then we're going to call those linked or nested templates in another template. This approach allows us to reuse components across different projects and environments, saving time and reducing errors. For example, you may have a template for networking, another for storage, and another for compute resources. By linking these together, you can quickly assemble complex solutions and update individual parts without affecting the whole system. Modular templates also make troubleshooting and extending our infrastructure much easier. If you run into a problem, you can focus on the specific module rather than sifting through a huge file. Azure supports deployment modes like incremental, which only updates resources defined in our template and leaves everything else untouched. And it's also recommended to use one resource group per deployment for better organization. For added security, you can store external templates in a private storage account or use a SaaS token for access during deployment. This modular approach streamlines your workflow, boosts reusability, and helps keep your cloud environment secure and well-organized. When deploying resources in Azure, you'll often need to pass sensitive information like passwords or connection strings securely. Instead of hard-coding these secrets into your templates, Azure recommends using a Key Vault. In this approach, you create a Key Vault and store your secret there, then reference it in your parameter file, not in the template itself. This keeps your secrets safe and ensures only authorized roles like owner or contributor can access them during deployment. By separating secrets from your infrastructure code, you reduce the risk of accidental exposure and make your deployments more secure and manageable. Now let's look at implementing Bicep. So Azure Resource Manager has been around for a very long time, and a newer, more modern version is now generally available, and it's called Bicep. Azure Bicep is the next evolution of Azure Resource Manager templates. It's designed to make deploying resources in Azure simpler and more efficient. Think of Bicep as a domain-specific language that lets you describe your cloud infrastructure in a clear, declarative way, meaning you specify what you want and Azure figures out how to make it happen. Bicep files are more concise than traditional ARM templates, automatically managing resource dependencies and encouraging code reuse and modularity. Plus, Bicep is open source and integrates seamlessly with Visual Studio Code, offering features like IntelliSense and linting to help us write reliable templates. And Bicep CLI allows us to transpile Bicep files into ARM templates and deploy them, or even convert existing ARM templates to Bicep for easier management. Getting started with Azure Bicep is straightforward and designed to give you a smooth authoring experience. To begin, you'll need to install the Bicep CLI, which works across Windows, Mac OS, and Linux, thanks to Azure CLI's cross-platform support. And you can install Bicep using commands like AZ-bicep install, charcoal install bicep, or winget install -id microsoft.bicep. For those who prefer a graphical interface, the Visual Studio Code extension for Bicep is a fantastic option. It adds language support, IntelliSense, linting, and makes it easier to write and validate your infrastructure as code as you go. When working with Bicep, understanding the file structure and syntax is key to building reliable infrastructure as code. Bicep files are designed to be easy to read and maintain with clear sections for scope, parameters, variables, resources, modules, and outputs. And the scope defines where your resources will be deployed, like a resource group or a subscription. Parameters let you customize deployments by providing values such as names or locations, while variables simplify complex expressions and make our templates more robust. Resources are the heart of the template, declaring what we wanted to deploy, and modules will allow us to reuse Bicep files across different projects for true modularity. Outputs are handy for passing important values like connection strings or endpoints back into our pipeline or into a terminal after deployment. And Bicep also supports advanced features like loops, conditional deployments, referencing existing cloud resources, and making it powerful both for simple and complex scenarios. The syntax is straightforward, and with built-in validation, you can catch errors early before your code is deployed. The structure not only streamlines the deployment from this structure, please. This structure not only streamlines the deployment process, but makes troubleshooting and scaling much easier. Whether you're deploying a single virtual machine or orchestrating a multi-tier cloud solution, Bicep's organized approach helps teams maintain consistency and reduce errors and automate infrastructure with confidence. Another powerful tool for creating and managing resources in Azure is the Azure Command Line Interface, or CLI. When working with Azure, the Azure Command Line Interface is our tool for managing cloud resources directly from a terminal. So whether you're using Azure Cloud Shell or PowerShell or Bash, instead of clicking through a web browser, you can execute administrative commands like restarting a virtual machine, or simple commands like azvm restart -g my resource group -n my VM. Now note, the syntax pattern that we just talked about there is AZ for Azure, and then the thing you want to work with, in this case VM, the action you want to take, which is restart, and then any required or optional parameters you want to supply. In this case, that was the resource group and the name of our VM. The Azure CLI is cross-platform, so you can install it on Linux, Mac OS, or Windows, and even add it as a module to PowerShell. This flexibility means that you can manage your resources interactively by typing commands at the shell prompt, or automate tasks by assembling those commands into a script for repeatable deployments and maintenance. Working with Azure CLI is all about streamlining how you manage resources in the cloud. The CLI organizes commands into groups and subgroups, makes it easy to find exactly what we need. For example, if you're looking for commands related to blobs, you can use AZ find blob to quickly locate them. If you ever want to, unstuck yourself, you can find more details by adding the --help argument to a command, like AZ storage blob --help. This will provide an instant guidance on syntax and usage, and it helps us navigate the CLI efficiently. So whether we're creating new resources, managing storage, or troubleshooting issues, it's going to work for us. Let's go to a demonstration and look at how some of these features work. Here we see an example of Bicep in Azure DevOps. This is part of our infrastructure as code approach. We can see the layout of parameters and settings at the top of our file. And we can see the resources we're deploying below, including allowed settings, and reusable variables are listed as well. Each resource and its settings are included in the pipeline. And in the pipeline, we include a deployment. And when running, we can observe the pipeline and validate its success and view feedback from the command line interface. And it looks like we have success. If you'd like to go deeper and run the AZ-400 lab exercises using your own accounts and subscriptions, you can find the self-paced labs on GitHub at Microsoft Learning at /mslearn-devops. And if you prefer structured guidance, you'll also find options for instructor-led AZ-400 training with live labs and expert instruction on Microsoft Learn at the AZ-400 course page. This concludes our session. There are many ways to continue your learning journey, and we encourage you to watch the other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.